Hello everyone, welcome to day 8, I think we're on day 8 of TCP IP chat application. I think at the end of last time I said I was going to look into keep alives, but before we do that, I want to clean up some of our parsing code, and this will just be a little bit of cleanup here at the beginning. We'll see how much time this takes. I'm just not really happy with some of the code as it stands right now. I think it's just too complex. Let me switch over to my screen and show you what I mean. All right. So where are we at? We're kind of in the middle of this chat connection type here. So this is the type that does all of our parsing and serialization, and I want to clean up some of this code for sure. So here's where we're writing out. This code, as was pointed out yesterday a couple times in the chat, has got a lot of magic numbers in it. You know, it's +8 and 4 plus 4 and all this. So that's one aspect of this. It's got a bunch of magic numbers. Another thing is I'm using a mix of these like binary primitives and then copying spans and that kind of thing. And it's just not clear when you're reading this code what it's actually doing, right? You can't read through this and say, oh, that's obviously correct, right? And that's where we want to get to. So that's the encoding part, and then also the decoding part. There's a few things I want to clean up over there too. So like this try copy to that behaves differently than all the other try methods on the SequenceReader type. That kind of bothers me. SequenceReader is a good type. It's just this one API that annoys me. And then the other thing that we have here that I'm not wild about, I'm going to see if we can get rid of this, is all this repeated, well, I didn't get the whole message, so advance the pipeline and then, you know, break out of the attempt of getting the message. So I'm going to see if I can clean that up too. We'll see. But first off, you know, the more egregious code up here, which is just really, really hard to understand right now. So I'm going to take a little bit of time. I want to clean this up. I did last night look for some kind of like a memory writer, although technically I think it would be a SpanWriter that would handle this, or you know, that we could use to help clean up this code. And unfortunately, I didn't find anything. It looks like the one thing that I found was in I forget what it's called, but it's essentially like the .NET team's repository for experimental things that may or may not become part of the framework. So they actually had like I think it was a SpanWriter was what they called it. And so they actually had one that they had started writing, and it actually didn't behave exactly the way I wanted anyway. And then they ended up not putting it into the framework, I assume, because that code is actually, that I found was actually like an archived version, and it's not even in that repo anymore. So that was apparently an experiment that they decided not to proceed with. But, you know, a SpanWriter is the kind of thing that I want. And actually by writing our own, we'll be able to do our own kind of primitives on it. So we can say, you know, we've got our, let me bring up the protocol document here. So we've got some types that we're starting to define in our protocol document, like this variable length short string. Well, I could actually make that as a call on my span writer, you know, write out this variable length short string. So by actually writing our own, we'll get some benefits anyway. So let's jump back here and let's get, oh, you know, actually there was one other thing. Somebody mentioned on Twitter, Lars has mentioned, my inner GC just wants to notice that broadcast message is immutable and can be created once outside the loop. Yes, thank you, Lars. Let's fix that first. So what he's talking about is in our server logic, we've got message. Yes, this new broadcast message. This is always going to be the same for every incoming chat message. We're just going to pass the same broadcast message to all of them. Now, if you're not, well, yeah, I guess that would always make sense. I was thinking if your message types weren't immutable, you might want to new up a new one each one here. But actually, yeah, I don't see any situation where this would be misleading. So we can just say, move this up here and just create it once, is what Lars was suggesting here. And of course, it's got to be inside that if loop. You can create it up here. Where's my from? Right. So I should have paid a little more attention to what I was doing. Okay, and then we can send that same broadcast message instance to all these different connections. Thank you, Lars. All right. Lars says, thank you. All right. I know when you see things like that, it could be like, oh, wait, that really annoys me. Okay, so no, we won't commit that. Okay, so back to chat connection. I'm just going to clean up this code here. Right now it's a huge mess, right? This is almost embarrassingly bad. I apologize. So let's see what I want to do here. I think what I'm going to want to do. All right. I'm going to want like some kind of a SpanWriter, but really. So the question is like, where am I going to put this? So I could make it a, just like a. I could make it in the same file, right? We could stay within the chat connection file, within the chat connection class, and just define these like parsing and serialization helper methods. But I think what I'm going to do is actually move it into a separate type, and I'm going to make it internal. And this is something I don't often do, but I just want to try it out this way. We'll see how we like it. So I'm just going to do, let's call it chat serialization, or just message serialization. How's that? And I don't normally use internal classes, actually. As a general rule, if you have a type that is useful to you, and you're writing a library or whatever. Most of my open source coding is libraries. So if I have a type that's useful to me, and but it doesn't have like a fully fleshed out public API. It's not an API that I want to support, right? But it's useful to me to have that as a separate type. Then usually, what I will actually do is not make an internal class. I will make it a public class inside of some kind of a namespace that that indicates that it's not actually part of the API of the library. So it's in an internals namespace, for example, or in an implementation namespace, to make it clear that, hey, even though I'm exposing this just in case someone else wants to use it, because the idea here is if it's useful to me, it's probably going to be useful to someone else. And even if it's not a complete type and not fully, not an API that I support, not something I consider the surface area of the library, it's there if you need it. And let's see, actually David Fowler, when I was talking about this concept on my blog, David Fowler came along and said that Microsoft refers to these as pubternal. So they're public, but actually internal, right? But they're also public if you want to use them, wink, wink, but it's on your own, right? Like they can change the API at any time because they are actually internal. Now in this case, I'm going to actually use an internal class. Like I said, unusual for me, and we'll see how I like it. But I'm actually going to use an internal type, I think, because this message serialization actually, like logically, is part of the chat connection type. And I'm just breaking it out just to keep the code a little cleaner. So really, it's more of a partial class, logically thinking, than it is an internal class. Okay, so that was way too much talking about just a one design decision there. All right, so so what I'm gonna want is, I'm definitely gonna want a type called, so this is gonna be like a SpanWriter, right? That's what I want. And it's going to take a span of bytes as its buffer. And what I want to do is, the whole point behind the SpanWriter, so let me show you the check. Let me show you what I'm thinking here. Okay, so the whole point behind this is, as we're writing out a message, let's look at this broadcast message because it's got several fields. So first we decide what we're going to write, right? This is determining what all we're going to write. We're determining our message length. We're getting our memory. That's all pretty straightforward. And then this part over here is what I want to kind of encapsulate. Is this, first we're writing this big endian 32-bit integer. All right, fine. But now I have, like, in the code, I have this implicit offset, right? I have written 4 bytes for that 32-bit integer. So then I'm slicing the span. I'm saying, okay, well, write the next byte. And now I have an offset of 5 bytes. Or sorry, no, now I have an offset of 8 bytes because I've written 2 uint32 types. And then we write, so I've got this offset of 8 here. And then I write in 1 more byte for the from length. And now I have this implicit offset of 9 bytes. And then I can actually copy this data in, and then I have an offset of 9 plus however many bytes I just wrote. So I've got this like implicit offset that travels through this code and just keeps getting added to these other values. What I want to do is pull that out into a position, right? We'll call that a position. So this will be I'm going to want this buffer first. And I'm also going to want, not read only, I'm also going to want a position. All right, so the idea is, as I'm calling the methods on the SpanWriter type, it'll keep track of my current position for me, and I won't have to, have that ugly code in there. And this, right. So this SpanWriter type actually can't be a class. It has to be a ref struct, and this is something that I'm not as familiar with. I think this might be the first ref struct I've ever actually written, other than just, trying out things. But the idea here is, because a span is, it can live on the stack and so on. So essentially a local span variable has to be on the stack. It can't be boxed or end up on the heap. And so because we have that span member variable, the SpanWriter also becomes a stack-only type. And what actually ends up happening is this SpanWriter actually ends up being some local variables, right? So when we excuse me. So when we declare a SpanWriter in here, what's actually going to happen is it's almost like, here's a grouping of local variables, right? Okay, so now we've got this SpanWriter, right? Okay, so we've got our span. Let's name this span just for consistency. And do we need it? Yeah, we need to set position, which is interesting. You'd think. See, I don't understand why you actually have to set position to 0 there, but okay. That's the part of ref structs that I'm not as familiar with. With a regular struct, it's just automatically 0. Okay, so now what we want to do here is be able to do things like say write, well, actually we've got a type here that is pretty much what we want to do. So we're going to kind of duplicate this just so that all our things are on the same type. And I'm thinking I'm going to come back here and make these more like logical, like instead of, well, I'll show you. So we want to write a unsigned integer. And this is actually going to be, let's see, so we've got that, that binary writer already. Or binary primitives, sorry. So we will just do this. Actually, we want that one probably. So we're going to write to this span. Let's pull this in. And we're going to want to slice it at our current position, right? Because we're always going to be working from our current position. And I'm just going to limit this to a size of uint. And then we're going to pass the value in to actually write. And then I'm going to increment my position by the number of bytes that we've written, which is that. So now, actually, I'm doing two things at once. I'm pulling out that write, and I'm building this new type that's keeping track of the position for us. And I'm also removing the magic numbers. This is no longer 4, it's now size of uint, which makes more sense. Really, these ones back here should have been like size of uint, size of uint. Well, actually, this one is just the position. But anyway, yeah, you can use size of to more properly determine make the code a little clearer. All right, and then we're going to need the ability to write a single byte. Okay, so let's do that. I'm just doing the really low level stuff first, and then what I want to do is do the higher level stuff, like write out a byte prefixed length string, one of those short strings. But let's do the basic stuff first. So we can just do write byte. Okay, and in this case we are going to do the span. Yeah, okay, so we can just reference right into this and say, here's my, I'm at position. Oh yeah, that's actually a good suggestion there, IntelliSense. All right, so we're just going to say, that's all that write byte needs, is we're writing one byte into the span and incrementing position. Piece of cake. All right, it's a lot. This code, I think, is a lot cleaner than this code. That's just horribly awkward. All right. Well, I guess I didn't need to divide this. I could have just done span 8, right? That would have been better. Yeah. Okay. All right. We're cleaning up the code. And then we need to copy a byte array in. Now, when we're writing, this is always going to be like the full byte array. There's no like partial writes or anything like that we're dealing with here. This is all serialization logic. So let's see. Yeah. Okay, so in this case, we want to copy the span, just like this one does, which is going to be very similar. So we're going to say our value is going to copy. Oh, you know what? Actually, let's copy span to span, because we're doing spans here. So this should be a read-only span, right? Yeah, okay. Then we can copy that into our span, which is going to be sliced at our position with the span length. All right, and then we can just increment position by the span length. This is the number of bytes that we have copied. All right, so now we've got these, we're building up these primitives here, and this is this all we need? Unsigned integers, bytes, and byte arrays. I think that's all we need for like the really low level stuff. So let's go ahead and start using this type and see how this cleans up the code. It's not going to be fully clean yet, but then I'm going to like move some higher level stuff into the message serialization as well. So this is defining how we are writing. Okay, so this, I think I can't use this directly. I think I'm going to have to, because this is an asynchronous method, we've got this await for each here. And because of that, I don't think you can use a ref struct type because they can't go on the heap. but let's see. Just trying to decide where I even want to do this, because if we do this like if we pass this in here as where are we at? Memory.span is what we're writing to. That's, oh, silly me. Okay. Memory isn't in scope yet. So let's just do this one first, and yeah, you can't say, oh wait, that's not what that's complaining about. It is saying parameters or locals cannot be declared in async methods, right? Because it's a ref struct, it can't go in an async method. So what we're going to have to do is break out like the synchronous part into a little helper method, which we can certainly do. So I'm going to call this like, I guess, write message. And we've got and then iMessage. And we'll just copy out this whole part here. We'll just do that. And then this write message comes down here. Okay, so now we have a synchronous method that can have a local variable of a writer. Okay. Oh, and everything else just works. Okay, I don't have to fix up anything else because pipeline socket's actually a member variable, so we can get our memory and everything like that. All right, that worked pretty nicely. So I'm going to new up this SpanWriter, and I'm going to say, now we're going to start, replacing all this other stuff with the actual writer. So I'm going to say writer dot, yep, and then that will be our, this will be our total message length. Which in this case is, I'm just going to keep this here for now. And I think I'll come back and remove some of these other magic numbers in a minute. I just want to finish this first. And then we write 0. Yes, 0 is the message type for this message. And then we write out this byte array of text bytes. Yes, exactly. And then we call it advance. All right, I'm going to come back and fix these other magic numbers in a minute. I'm just going to do this same SpanWriter here for after we get the memory for our broadcast message, which is a little more complicated. And this is where we're going to see more of the benefit when you have multiple fields in the same memory. Okay, so we've already got a message length here. And then we're going to write out the type, which is 1 for this message. And then we're going to write out, so now we're going to write out that byte prefixed short string. And this will be just what we have here. And then we've got this byte array for the from bytes. And then we've got a byte array of the text bytes. Right on. Okay. So I like that. All right, so this, now instead of sometimes we're using binary primitives, sometimes we're copying spans and that kind of stuff, and we're keeping track of our position as we go along, that offset. Now that's all inside of the SpanWriter type. So that cleans up the code quite a bit. it's still got some magic numbers in here. So yeah, let's clean up this this advance here first. Okay, because we've got this memory, and that's exactly what we're advancing by because we calculate the memory ahead of time. All right, so each time when we get the memory, we're passing that same thing in. Okay, so what I'm thinking is this value here is always going to be our ending position because we're using that, that SpanWriter. This value, whatever this value ends up being, is always going to be the ending position. We have ending position of 4, 8, and then whatever the text bytes is. And down here we have 4 plus the message length, which was already calculated up here. Another 4 for the type, 1 for the prefix, yeah. So what we're going to end up here advancing the output pipe by is always going to be our ending position on the SpanWriter. Whatever we've written, that's what we're going to advance in the pipe. That makes sense. So let's expose, where'd that pipe go? In our SpanWriter, I'm going to expose a I don't know why I have this message serialization type here. We'll deal with that in a minute. All right, so let's expose the position. So we've got a all right, so now we can take that and say, instead of just advancing to this, calculated value, I can just advance as far as I've written, which is a much more obviously correct piece of code. All right, so now what have we got? We've got, right now we're still writing out like, what would you call it? Like primitives, right? And I kind of want to like lift those up into more logical types. I'm not sure if now is the time to do that though. Where are we at? Yeah, I think so. And I think I'm going to keep this. Okay, so let's see here. Let's do some higher level types here. So this will just be, and this will just help us. Some of this is just to make the code a little more self-documenting. So I can say like write length message length prefix. Yeah. And this is going to be, this is what it is. And I can say write message type. Those are the easy ones, right? They just forward. But if we use those in our code, now it's becoming a little bit more obvious that, okay, this code is, clearly following the protocol, right? We've got our message length prefix, our message type. We still got some primitives in here. Let's clean that up. Well, the write byte array can't really go away yet, but this thing definitely can. We have that type defined in our protocol, that variable length short string. So I'm just going to call it that. Right, variable length short string. Now, the type we're going to take for this can actually be a string. Or should we pass a byte array? I'm kind of thinking, let's go ahead and make it a string. The only hesitation I have here is that we might we'd be encoding twice just for a little bit because we're not correctly predicting we can't predict what we're doing right now is we're not predicting the length of the bytes when the string is UTF-8 encoded. We're not doing that yet. But once we do, then we won't be double encoding anymore. I'll show you what I mean in a minute. So when we're going to write this variable length short string out, and this is composed of a byte prefix of the length. So we're going to grab our bytes here, and this is going to be yes. And we're going to, actually what I'm going to do here is put in that bounds check also right here. And this is just going to be the we lose some of our context here, but it is what it is. All right, so then we can write out a byte of the length, and then write the byte array as the bytes. Okay, so now we've got this. Now we've got a primitive, if you will. So that's actually a little bit more higher level. That's not actually as primitive. So let's bring this over here and say we are going to write out. So this is the only field that we have right now that's a short string is this this from bytes. So this will be broadcast message.from. Okay. Now the one thing that I'm not happy about this solution is we are encoding the from field first over here, just to get the length now. And then we are encoding it again inside of this, this writer method. So you don't want to do that. But what we can do is get byte count. Yes. So now we have a from bytes length value, and this doesn't do the encoding. It does run over the string again. So there's advantages and disadvantages to taking this kind of an approach. If you have like really long strings, you know, if you're going over them several times, just determining how many bytes will this take, that's usually not a good idea. In this case, I'm going to say it's fine. All of our chat messages are going to be pretty short, and actually in the general case, I guess you could say most string messages are going to be short, right? So any kind of a string field is usually short enough where you can go over it once to get the count, allocate, or in this case, you know, get the memory from the pipeline after you know how much memory you need, and then actually do the encoding. That should be fine. All right. If you were talking like super high performance sockets, you wouldn't want to, you know, you might want to do even trickier things, but this should be fine. You know, I'm going to compile this and run this just to see with our new SpanWriter if we're still going to work. Hopefully. Let's run our chat server, and yeah, chat client is still in the debugger. So let's do this. We can connect, and when we send a message, it gets the message just fine. Okay, cool. Closed it. All right. So we've cleaned that up a bit. We've gotten rid of all of our like position, offset, manual calculation, which is really nice. I like that. There are still a couple things that I want to clean up here, and what we're actually going to end up doing, what I'm thinking is we want a way to say like, we want to clean some of this up and say we want to get our, let's see if there's a way to get a length, you know, a necessary length for a message. Let's abstract that out into our message serialization here. So I'm just going to put this here for now, I think. So I'm going to turn, I guess we'll just call it get message length. And this will be an iMessage. Okay. Now, at this point, there is something else that's going to start annoying me. But when you've got this kind of if, else if, we've got essentially a switch on our message type, and we're throwing for an unknown message type. This is a pretty good code smell, actually, indicating that, hey, what you're doing would be better represented as, say, a method on a base type, or an interface in this case. I'm going to leave it as is for now, but that is something that I'm aware of, and it's starting to be especially that I've got this twice in the code, this is starting to raise a flag here, saying, well, that may not be the best solution. So really what I want to do here is I want to just determine what the length of a message is if I were to encode it. So in this case, we've got the chat message, which is just, so we're going to take, just like here, we're going to take this byte count for the text bytes length. And this is going to be our length prefix. And here's where I'm going to, also start getting rid of some of these final magic values. So let's do let's see. So we actually want the message length prefix length. So this is the actual length of the length prefix. So I'm just going to say length prefix length. That'll make it a little easier. And this is And we're also going to want the message type length, which is also going to be an unsigned integer. So then when we return from here, the size of a chat message is just the length prefix length plus the message type length. All messages are going to start with that. And then just the text bytes length. Don't you love integers? C# is not terribly friendly towards unsigned integers. Something you will notice if you do a lot of low-level serialization. Okay. So then our broadcast message is we want to get our from bytes length for sure. We can ignore that. We need our text bytes length also. And then we've got the nice little message length right here calculation, which we can use as a framework here. So this will be the length prefix length plus the message type length plus our single byte prefix. I guess that could also be. So this would be what did I call this? The variable length short string length prefix. I'm going to change this to just short string, because calling this variable length everywhere is just really is too long. So this is going to be the short string length prefix length, which is going to be a single byte, which is going to be 1. All right, but this is like making it really, really clear in the code. It isn't about determining what the size of an unsigned integer actually is. This is documenting in the code that we are following our protocol. So the length prefix length plus message type length plus this short string length prefix length. Just don't like that. It's getting too complicated. Plus the from bytes length, and then plus the rest of the message is just the text bytes length. Okay. And then we've got to do our casting again. Also. Okay, so that should work for getting our message length. Can I do it right? There you go. So now we have a way to like generally get our chat message length, or our message length for chat messages or broadcast messages. So what I'm going to want to do is say here we're going to get this memory. When we call get memory now, we can just pass this in. Message serialization, get message length of this message. And what's the problem here? All right, fine. It really wants to use signed integers for getting memory. Okay, fine. I'll just change this back. We'll make it easy. Make all these integers. Oops. Let's get rid of all this. Simplifies my code anyway. That works. All right. So now we have an integer messenger length, which is fine. It's just really an unsigned integer. Okay, so now we're gonna get this message length and then this text bytes. All right, so we've got our message length. Yeah, so I did do something kind of awkward here with the protocol, where the length prefix does not include the length of the length prefix. So that's why we have like multiple different message length ideas in here. So we're writing this message length prefix. It's got to be, okay, so let's get our message length first into a separate variable here. So really, do we want this one to include the length prefix or not? And I'm kind of thinking maybe we don't want the length prefix in there. So let's say get message length. Let's just make this explicit without length prefix. And we will remove the length prefix from these calculations. So this is actually like the length prefix value now. So let's do that. Let's do this get message length prefix. Okay. So let's come back over here. Get message length prefix. So this is going to be the message length prefix, which does not actually include the 4 bytes for the length prefix. This is getting really confusing. I think I might change the protocol just to make this clearer. But let's finish it up the way it is first. So for memory, what we're going to want is the length prefix length plus the message length prefix value. Okay. I'm going to rename this to that. Okay. So now, when we write this out, we can just write out, here's my message length prefix value. And that's it. Yeah, okay. So let's do the same thing down here for our broadcast message. Actually, there's one more thing up here I want to change. Now we're only passing these encoded bytes into this byte array, which is fine. So I'm just going to get rid of that member variable. Okay, local variable. So now I want to do this something very similar up here, or down here for the broadcast message, and this should clean up the rest of these magic values. So we've got the message length prefix value from the message, and then when we call get memory, it's always going to be the length prefix length plus whatever that is. So let me come down here to this. Oh, and we've already got message length being calculated here. This just goes away because this is now we're already calculating that in this other type. And then our from bytes length, we are doing that check and throwing that exception in our encoding of the variable length short string, which is now just short string. And is that it? Okay, text bytes is, we can get rid of that local variable as well. Okay, so now both of our serialization codes here are doing very, very similar things. They're determining how long the message actually is, right? What's that length prefix value actually going to be? It allocates memory sufficient enough to hold that length prefix value plus the actual length for the length prefix. And then we spin up a SpanWriter that we use to fill in that memory. And we're writing the message length prefix, we're writing the message type, and then the rest of it is message specific. The chat message is just the text. The broadcast message is first a short string for who the message is from, and then the text. Okay, so this is actually like looking much, much better now. You can read through this code and say, yes, it's obviously correct. I think this this length prefix length thing here is annoying me sufficiently enough that I might change the protocol a bit. No, actually, I'm not going to do that. I'm going to leave it as is. I like it this way because, yeah, I like it this way. We'll be good. Okay. I'm trying to decide if I actually want to change it or not. So right now, the length prefix has to be for, I'm going to keep it as is for now because I want to think about how I want to do keep alive messages, which it looks like we're not going to have time to get to today. Sorry. So we've got this, let's run this after these last changes here, where our code is much, much cleaner. And even over here where all our serialization code moved to, it's still quite clean. We've got these very clear sizes as defined by the protocol. We've got calculations for how big the messages are. And then we've got these, write types that each method now is, yes, that's clearly correct, right? Where the code is much, much easier to understand and more obviously correct. So let me jump back over here into my chat server and kick off our client. Sorry, today's been mostly just cleaning up the code. Sometimes you just need to take some time to do that. And I don't know where my, that was weird. Ah, okay. I don't know what's going on here. I don't know what that was about. Okay. Let's connect. Got a connection. Let's send a message. Got a message. All right. Can we send a message back? Let's see. Let's jump over to here and kick off another client. So if we connect over here, then if we send to the other, then we sent the message other, and the other one gets that message from this connection. Yes. Okay, good deal. So that all looks good. It's all still working. Nice to know. Okay. Time for a write remaining text for the message, .text for Lars. Yes, so, right now we're still writing the text as byte arrays. We definitely, that's a great idea. The only thing that I'm thinking is actually I'm planning to remove that from the protocol. So why don't we just go ahead and do that? Let's change our protocol. I think it's a good time to actually change our protocol. So one of the things that, and I know I mentioned this on earlier days, is I don't really like the remainder of the message kind of things in my protocols. I'd rather have everything have, if something's variable length in a message, it shouldn't just take up the remaining space. Instead, it should have its own length prefix. That's just the way I like to do things. So I'm just going to go ahead and do this. So I'm going to define we've got a short string which goes up to 255 bytes. That's plenty of room for a nickname or a from address. What I also want is what I'm going to call, I'll call it a medium string. We'll call it a long string. So this will be very similar to our short string. Length prefix UTF-8 encoded, where the length prefix is a 2-byte unsigned big endian integer. Okay. Or big endian unsigned integer, I think makes more sense to me. Not that it really matters. This is text. But, okay, so so this allows a text message up to 64K, which should be plenty. Instead of just using up the rest of the chat text. So what I'm going to do, I'm going to bump my protocol version first. And I'm going to say changed text fields to be long strings. All right. So now this is completely, what I'm doing right here to the protocol is completely backwards incompatible. All right. I'm only doing it because we're still like pre-release. It's 0 point whatever. So I'm kind of like, I'm allowing myself backwards incompatible changes right now while we're developing our app. Once this gets published, you can't make a change like this. You'd have to like introduce a different kind of chat message. Okay, so let's see. The payload of the message has a single field. Now, like all of our payloads are actually fields, which I like. So this is a long string, so we don't have to say UTF-8 encoded string anymore. Representing the chat text the client sends to the server, fine. And then this one is, instead of being the remainder of the message, it is now a long string. Okay, so let's go ahead and implement this. And this now brings the protocol more in line with what I like to do with my protocols. Everything's length prefixed. If everything's variable, everything variable is length prefixed. Okay. All right, so let's jump over here. Now, let's see. So the way that we want to do this is we still have this byte array, yeah, okay, but we're not going to be using it for the text fields anymore. Instead, I'm going to take this, we've got the write short string. I'm going to do the same kind of thing. I'm just going to say write long string. We're going to do UTF-8 encoding. I'm going to check. This is still a magic value. Let's get that out of there. So instead of byte.max value, I'm going to be checking for ushort.max value. Okay, and then I'm going to write okay, so we don't actually have a way to write the, let's do that. Our short value, so we want to do write uint 16 big endian use short value. And this is going to, hopefully this is on the binary primitives. I actually checked. Yes, it looks like it. Write uint 16 big endian. Perfect. We got the easy way. All right. So let's actually copy this and then change it to be for short values. So we're going to slice into here. This is the size of uShort. We're passing along the value, and then we move up our position by the size of uShort, which is 2 bytes. Okay. So now we have the way to write an unsigned integer, 16-bit big endian integer to our span. And so now in our write long string, what I want to do, instead of writing the byte, I'm going to write uint 16 big endian, which is actually the uShort of bytes.length. Okay. And then we actually write the byte array, just like we were doing before. So now we have this way to write a long string. Okay. Now we're going to change our message parsing, not parsing, well, we need to change the parsing too. We need to change our message, what we need to do is change our calculation of the message length, change how we write the messages, and then change our message parsing. Let's see if we can get this all done today. So we're going to go in here where we're doing our length prefixing, or length prefix calculation. So now we have, we should have a long string length prefix length, which is going to be the size of uShort, which is 2 bytes, or 2. So now we've got, now our chat message is going to have the message type, long string, and a long string essentially. So our long string length message prefix plus however many bytes are in this message. And our broadcast message is going to have, I'm going to split this out a little bit. So I want our short string plus the from bytes plus the long string length message prefix plus the text bytes. So that we've got our message type, we've got our short string for the from field, and we've got our long string for the text field. And I like how that splits up more in the code there, keeping the related ones close. All right, so we've handled our length prefix calculation. Let's jump over to our writing. So now we're writing our message length prefix, we're writing our message type, then we want to write a long string. Write long string, we're passing that chat message.text, and our encoding is now gone. Same thing down here, we're already writing the length prefix, the message type, the short string, we're going to write the long string. And our encoding is gone. All right, so let's take a look at our reading. We still need to handle reading these new types, or these changed types. And this one, all right, so we've got, if our message type is 0, previously we were just reading the rest of this thing as a byte array. Okay, so we've got the length prefix -4, which is another magic value. Okay, I don't see any other magic values up here. So let's see if we can get rid of this and also the magic value, maybe. Actually, yeah, I should, oh yeah, I like that. Ooh, I really like that. So let's just, I'm gonna put a to-do in here. Read new message types. Or actually, type, read new message type layouts. Okay, I don't know what to call it. All right. What I actually want to do is take like this, all this code, and say, let's make an extension method on SequenceReader that reads a short string, right? Let's clean up this. So let's do that. I do have a static type here, so I'm just going to make an extension method here Let's see. Oh, this will be a Boolean because we're going to structure it like the other sequence reader types and make it like a try read short string. Okay. And this will be just trying to figure this out here. So sequence reader byte. Pull this in. I'm not sure because this is like a ref type, isn't it? It's a ref struct. So can I do this with a this? Can I do a ref this? I don't know. Looks like it. All right, here we go. Let's see if this works. We're gonna try to read, and so if we can't read the length, which is a single byte, then we return false. Oh, and of course we need a place to put this. So I'm going to say out. I'm going to go ahead and call this string. I'm going to read out the value. Here we go. So value is going to be null at the beginning. Yeah, we can do that. Okay, so we're going to say here's our bytes. This is not the from field necessarily anymore. So this is going to be our length. We're going to new up the bytes. I'm just going to keep with this buffer copy. There's ways to make it more efficient, but it's too complicated right now. And then we're going to copy to these bytes. If there isn't enough space or enough data in the sequence reader to copy it into all the bytes, then we're going to return false. Otherwise, we need to advance the sequence reader position. So this also removes that awkward API of, hey, try copy to doesn't work like try read. From bytes.length is the same as just length. So I'm just going to use that. Cool. All right, and return true. All right. Hey, let's try that out. I've never written an extension method for a ref struct before, so let's see if that works. Where are we at? So this then looks like, oh, wait. Silly me. I didn't actually assign the value. So we're reading it into the bytes, and then I'm going to have to assign the value, which is, exactly what Visual Studio thinks it should be. Okay, that looks better. So let's see here. Lars has some great suggestions here. Oh, okay. Boy, I have not been keeping up with the chat. Sorry. We have add bytes, add finalize, and would write the length and message prefix only as a final step. Matt. Okay. So like a builder. So some people are thinking of like a builder API for like our SpanWriter. So that's possible. Yeah, actually. So we could. So what they're suggesting is like for our SpanWriter, instead of saying, where's our SpanWriter? Sorry, I didn't see wasn't looking at the chat messages. I apologize. So jumping back to a little bit earlier. So we're looking at our SpanWriter. Can we have like this thing, make it into like a builder kind of API where we say, add a message type, add a long string, that kind of thing, just like chaining off of each other. And then when it ends, it would be like, .finalize or whatever. And then that would actually take this position and go back and write the message length prefix automatically. You can do that. That is entirely possible. There's no reason why you couldn't. I think I'm going to leave the code as is for now, both for sake of time and because I kind of like it with, here's all the different things in order. One of the advantages of doing it with the builder pattern is because we are writing into a memory buffer, and we know that's already in memory. Well, no, actually, I was thinking you could calculate. You wouldn't have to calculate the length at the beginning, but in order to get the memory buffer, you do have to calculate the length anyway. So never mind. But yeah, so it's a stylistic choice, I would say then. All right, and Lars has a yes. So both Lars and Freddie pointed out, hey, you didn't set the value. Thank you. I will try to keep a better eye on chat. And Lars also suggests a not null when true attribute on the outstring value, which is a great idea. I'm not that, so then this helps the nullable value analysis to say, hey, when this returns true, then this value is not null. I'm not terribly good at remembering all of those. So thank you. All right, so that brings us up to date with the chat. I want to get through this reading the new stuff before I call it a day. So down here, what we're about to do here is use our new extension method for reading a short string. And we'll just see if this works. So this is now going to be from. And if it doesn't, if it returns false, then we have our usual false logic in there. And other than that, all of this just goes boom away. And oh yeah. Okay, I will come back and fix this. The other thing we need is we don't need this encoding. I will come back and fix that, just not right now. Because right now I want to do our new message type layouts. So let's see, actually, okay, I'll fix it right now. Just using a horrible hack by encoding this back. Actually, that won't even work, will it? Because you can have multiple different encodings. All right, forget it. Okay, so I want to read the new message type layouts here. All right, so now instead of just taking whatever our remaining bytes are and treating it as a text message, I want to read a long string. So let's add, I didn't actually test this out to ensure it worked. I should have taken things a little bit slower, I guess. So we'll be testing more than one change in just a minute. I'm going to try out this try read long string. And first we're going to read, can we read a try read little endian? Yes. Big endian. You want big endian. Network byte order. And this will be a U short. Will this work? Okay. So it's gotta be signed. Once again, there's just like these corners in the BCL that are like, oh, you can't use unsigned stuff. So fine. We are going to actually I'm gonna call this signed length and then introduce a new value. Just gonna cast this here. Okay, so now I've got my unsigned 16-bit big endian integer of the length prefix for this field, and then I'm going to copy over all the bytes and advance the sequence reader, and then return the unencoded string. Yeah, okay. So, boy, that was relatively simple. Okay, so let's see how this works. Now I can say I'm just going to copy this one from down here. Oops. So we're going to read a long string, which is into our text fields. And that's it. Boy, we can get rid of all this, and we get rid of the encoding. It's just the text fields. That's really easy. Okay, and then down here, we're reading a short string, and then we're going to read a long string right after that into the text fields. And then all of this, calculating, well, what's the remainder value, how many bytes are in the remainder of the message. We don't have to do any of that anymore because we're using nice length prefixing. Yeah, that really simplified that code. I'm very pleased with that. It simplified the code. Moment of truth. Let's see if it still works. Let's see here. So I'm going to kick off a chat server and a couple of clients. And we'll see. Let's both connect and send from one. Got the message. Hello, server. Yeah, it's working beautifully. Okay. So now we're actually using length prefixing for all of our fields in our protocol. Our parsing and serializing out code we've removed all of our magic numbers. We've made the code a lot cleaner. We've introduced that SpanWriter type to help that code, and then we've introduced a couple of extension methods on SequenceReader to help our parsing code. Let me see. There's one other thing that I'm not really wild about, and that's this repetition. It's this, anytime we don't have the ability to read a full message, then we have to repeat this code, saying, well, I've seen this much data, and then break. So there's a lot of this repetition in here. I'm still not very pleased with. So I think next time I'm going to finish cleaning this up. We'll get rid of that repetition, and then proceed to keep alive messages from there. So, all right, what we got? So Lars says you can return the short string length as an additional argument on try read short string. True. So we can read the string, or we can return the actual string lengths here. We don't actually need them because we're using advance on the sequence reader to kind of keep track of what we've already parsed, which includes the bytes of the string if it's there. And if it's not there, then our current parsing scheme is to just wait for a complete message is available in the pipeline before we actually handle it. So yes, I'm much more pleased with our parsing and serialization code now. Like I said, I'm gonna look at some way to clean this up next time. Tomorrow morning, yeah. And yeah, then we'll continue on with our protocol. There's one more thing I want to add to the protocol before it can really be considered complete. All right, so thank you for joining me on part 8. This has been part 8, probably of 10 or so, or 11. We're getting close to the end. Like I said, this is not actually production-ready code, even ignoring all the security problems, of which there are many. There's one major thing still missing, and that is keep alives. We still have to do keep alives. But it's looking good. Code is coming along, and I will see you on part 9. Thanks for watching.